let's do question 10 of the optical phenomena worksheet, and I didn't state where I got this from, so I can't remember. Anyway, so a potassium metal plate is irradiated. That just means we we just shine metal on it with light of wavelength 5 times 10 to the minus 7. We like this question because they've already converted to meters, which is great. The threshold frequency is 5,55 times 10 to the 14, so that's FO. They're not telling you if that's the threshold frequency, okay? Then, first thing they ask you to do is define threshold frequency. Now, if you've been working through the worksheets, you realize that we've asked work function lots. This is also another one of the important definitions. So, what is the threshold frequency? It's the minimum frequency of light needed to eject electrons from let's try that again. From the surface of a metal. Okay? Now they want the energy of the photon incident on the metal plate. Well, E equals hc over lambda. Let's do the easy one. Okay. 6,63 times 10 to the minus 34. This is 3 times 10 to the 8. And they told us that this was 5 times 10 to the minus 7. We put this all in here and we get 3,98 times 10 to the minus 19. Okay? Straightforward. We're all very, very happy. Now, they say use a suitable calculation and prove that the ammeter will show a reading. Okay? So, what we have to show, and there's more than one way to do this, okay? Either we have to show that we have a frequency, we have energy of the photon, which is what I've got here, which is bigger than the work function. So for me, this is the easiest. I know what the energy of the photon is, and if I look at the work function is HFO. We know what FO is. 6,63 times 10 to the minus 34, and they told us that the threshold frequency was 5,55 times 10 to the 14. So when I look at this, I get 3,68 times 10 to the minus 19 joules. So the energy of the photon that we worked out above is greater than the work function, therefore there will be a current. We could have also used, and it would be the long way around, we could have used this equation. And you could have worked out if there was a kinetic energy or not. If there's a kinetic energy, then we have a current. Either way, it doesn't matter. Then they say the intensity of the light is now increased. Explain why this causes an increase in the ammeter reading. Okay, so an increase in intensity increases the number of photons per second. Therefore, a greater number of electrons per second will be ejected from the surface. Okay. Very straightforward, and we like these questions. They look hard, but the more we do, the more we realize that they're all actually the same thing over and over and over again.